Ladies and gentlemen, please welcome Chief Technology Officer and co-founder, Grant Ingersoll.
Ain't it fun living in the real world? Ain't it good?
Welcome. As you can see, this is a adult beverage friendly event. So including the panelists here, we're going to also partake with you because, hey, why not? Welcome, everyone. I trust you all had a really good and engaging day. Lots of good sessions I saw on the agenda. Unfortunately, it's kind of funny when you work at Lucidworks and you come to your own conference, you don't actually get to go to that many sessions because it seems you're constantly in meetings with all of you great people. So I hope you at least got to enjoy the day. Really excited today. We're, just like last year, continuing on with a general session that I had a lot of fun at, despite being actually quite reticent to do, which was to host a panel. Generally speaking, you go to a lot of conferences where panels are kind of a mixed bag, and you never know quite what you're going to get. And I thought last year it was really a fun panel to really talk about what AI in practice means, and I think we come to sessions and conferences like this, you read the news, all of that kind of stuff, and there's just a lot of hype, right? The old joke, right? If it's machine learning, that's what we all do. If it's AI, that's what the press talks about, right? And I think that's in many ways the way I think about it. And so my goal with this session is to really give kind of just some insights into the practical day-to-day side of machine learning, of natural language processing, of statistical analysis. And so in many ways, my definition of AI is exactly those fields of research, right? How does this relate to search? How does it relate to discovery? How does it help understand users' intent? This is not about machines taking over the world and any of that kind of stuff. We can go have those discussions at the reception afterwards. And so, in many ways, in thinking about a theme for this, I really wanted to try to focus in on what is fact and what is fiction. And of course, it's a very evolving space, so things that are fiction today may very well be fact tomorrow, and vice versa, right? So in general, the way I've set this up is we're going to do a quick introduction to our panelists. We're going to spend some time on what it means to put AI in production. What are some people's wins? Where did things work for them? Where did they not? We've got built in some time for audience questions. So if you have a question for our panelists, there's some microphones throughout here. I ask that you do focus on asking a question. This is not your time to stand up and pontificate on AI, please. Right? So let's be cognizant of everybody's time here. Ask good questions. And then I want to spend a little bit of time talking about, I think what many of you are actually struggling with when it comes to all of this stuff is how do I hire people who actually know what they're doing? Right? How do you build a practice? How do you hire data scientists, data engineers? As you'll hear from one of our panelists, they now have a title of data strategist. How do you go about crafting a team that can actually tackle these kinds of problems and have a real lasting impact on the business? We'll have another session around for audience questions, so I would encourage you kind of as we get into each of these, and I'll have place markers in the slides. As we get into this, if you have a question that you want to ask, please do make your way ahead of time to that. And then we'll finish up with some talk around, hey, there's a lot of rainbows and unicorns, I think, when it comes to AI, right? So let's actually talk about some of the stuff that doesn't work. Just talking backstage with the panelists, we all kind of joked that we could actually spend the whole session just talking about the failures, right? So we'll try to limit that a little bit, and then we'll just wrap up and send you on your way to the evening event. Sound good? All right. So let's meet our panelists. First up is Dr. Alice Albrecht. She is leading the strategy and advising portion of Cloudera Fast Forward Labs. The coolest thing in talking with Alice, going way back, she got a PhD in cognitive neuroscience. And in the very early days of that, spent a lot of her time actually looking and using machine learning to analyze brain activity and then trying to classify that. So all this work around neural networks and all that has a very real meaning to her because she actually understands a lot of what's going on with the brain. So please welcome to the stage Alice Albrecht. Thank you. Next up, some of you actually may recognize who have been to past Activates, or as we used to call it, Lucene Solar Revolution, is Nick Caldwell, who is currently the Chief Product Officer at Looker. And by the way, I really want to ask him the question about the Google acquisition, but I can't. Well, I can ask him, but as he told me, he can't really tell me anything about it. So we're not going to talk about Google's acquisition of Looker, but you probably have known and saw Nick here a couple years ago talking about how Reddit was using Lucidworks Fusion. He's gone on now to lead up product at Looker. Generally speaking, has a long history of working in the business intelligence, data analytics space. So please welcome to the stage, Nick Caldwell. Super excited to also welcome to the stage Dr. Kamelia Aryafar. Now, Kamelia, you're actually going to get to hear from tomorrow morning as well. So we've got a bit of a 2-for-1 going here in terms of taking advantage of this opportunity to have somebody who's truly leading up a lot of really interesting problems at Overstock.com, whereas I actually think I've got her title wrong. She was just recently promoted, but on the slides here anyways, has her as Chief Customer and Algorithms Officer. I know she was also recently appointed to their board of directors. She's been working in search, especially retail search, for quite a number of years here, as well as having been a prolific author in the search and machine learning space. So please welcome Dr. Kamelia Aryafar. Last but not least is a longtime friend of mine who I've actually worked with at a couple of different places over the years in this awesome space of search and machine learning. I think I remember working with him way back probably 10, 15 years ago when I was at a tiny little startup called TextWise in the middle of nowhere, Syracuse, New York, where we spent a little bit of time working on some NLP problems and some search problems. But Dr. James Shanahan is currently a partner at Church & Duncan, which is a consulting firm based in Silicon Valley, where he does a lot of work really focused on search and machine learning. I know he's worked on autonomous vehicles. I know he's worked on very large-scale internet search. He's also the co-founder of a number of different AI companies. He I think, self-described himself as a farmer who then went on to be an AI machine learning engineer. He's published a bunch. He also has an academic bent to him because he spends some time teaching at UC Berkeley. So please welcome Dr. James Shanahan. All right, let me get settled here and make sure my iPad is working where I've got my questions. And of course, there we go. All right, so, let's get started. I think, we wanted to focus in on how do we put AI in production. And I thought maybe what we would do is start off with just simply asking every panelist, what's one of the biggest wins you've had in this space of machine learning, NLP, data analytics? Kind of describe the impact it's had. If you can share numbers or percentages, that would be amazing. I think everybody's always kind of trying to compare, hey, did I get 15% gain? Did I get 1% gain? What does all of this look like in reality? And so maybe Alice, if you can start off with maybe an example of your biggest win with machine learning.
Yeah, and so I think my biggest win in this space is probably not in the very exciting machine learning bits. It's really in terms of impact. So I was at Simple, which was a fintech company. So my team was able to create an algorithm using simpler methods that were more interpretable to increase people's ability to deposit checks, so increasing those limits for them. And the impact there was really interesting. We tried lots and lots of fancy algorithms, which the sort of like governance department said you can never use. We're never ever going to let you do this to people. And they had some incremental gains in terms of accuracy and predicting whether people would have an issue if they deposited more. But the biggest win there was allowing, let's say, around 10 to 25% of the folks, I don't think I'm allowed to say real numbers there, to have higher check limits. And the reason that was a win for me and for our team was that we were able to put this into production, and we were able to do it in a way that worked within the confines of a business, but also allowed us to experiment with a lot of different ways in which we could use these thresholds in other parts of the business. So.
Got it. And so many important things in there that I want to touch on as we go forward here, especially around the interpretability and helping businesses understand what's going on with this. How about you, Nick? Perhaps capture some of yours.
Yeah, sure. I'll briefly plug your product by saying that it actually is tied into one of the biggest impacts I had when I was VP of Engineering at Reddit. I don't know if any of you guys use Reddit. It's a site for cat pictures, and one of the problems we were having was people couldn't search for their cat pictures. So the original search was literally like 60% reliable. So basically slightly better than the coin flip, whether or not you would get any results for a single word query. So for better or worse, the most impact I think I've had technically is restoring search on Reddit to several hundred million people. But that's not the story I want to end on. I think the other one that I'm really proud of, similar to Alice, it's more about impact and change on the industry. I actually got my start in NLP doing natural language search over business data. So eventually at one point in my career, Bill Gates also, for whatever reason, I guess, got excited about this. He's like, hey, I can cure malaria, I can do search over business data, maybe do both at the same time. And I got pulled into a project which was around trying to unlock business data by making it accessible to everyone through natural language. And the project started about 7 years ago. It was called Power Q&A. And at the time, everyone said it was impossible, that it would be too difficult because business data is so esoteric and specific to particular industries and businesses. It would be too hard to make something where you could map a specific business's data model into something approachable by NLP. So we hauled ass on that thing, worked on it for 1.5 years straight, shipped it. And as of the most recent Gartner BI and analytics report, it's actually now considered industry standard. So I feel like really happy having really move the needle over the last couple years.
Yeah, that's really fantastic, and especially I think NLP is such an interesting topic in the way it's evolved, especially in the past 5 years, past 2 years with some of these newer deep learning models, and as I'm understanding it, this was kind of before a lot of these newer techniques are available. So you were doing it the old school way.
Yeah, man. I missed all the fun stuff. Maybe I could save this for later, but I am so Jimmy's going to talk about deep learning. But the stuff you can bring to bear with deep learning and NLP and machine vision right now, it's like we're effectively in a different universe compared to when I was doing it.
Yeah. And Kamelia, how about you?
Yeah, so that's a perfect segue for my example. So one of the biggest wins I have seen is taking advantage of images, because I have worked in e-commerce for several years, and e-commerce is a really visual experience. If you're looking at something that you actually like, you're going to buy it. But classically, machine learning just discards that whole modality of data, right? So it's all around text data or contextual data. So we have added images through deep learned feature, transfer learning into our models for personalization and for search. And those have been really amazing wins. Now, percentages I don't remember, nor I can talk about, I guess. But they have been really great. And more so the customer experience, right? The idea of you can design a whole room and have the style in mind, or just taking advantage of deep learning and the images and giving that to the customer, that virtual like showroom, for example, for furniture or the clothings and all of that, is really rewarding. And for a marketplace, there is another side to it that for search specifically, a lot of sellers tag stuff their listings with popular queries, for example. So I remember in Etsy, wedding dress was a really popular query, so every single thing, like a desk lamp would say wedding dress, wedding dress, wedding dress. So we launched this experiment that actually would take advantage of the images, and instantly it improved the quality of search so much. So that was a huge win. But the one I'm more excited about, I would say, is not an actual project. I would say I'm excited about this cultural shift, the experiment-driven culture, a data-driven culture. I think that, to me, has made the biggest difference in terms of leadership and how the company designs a strategy and how executes on it. I have seen that translate into really amazing product that has had bigger impact by far than any single project that I've worked on.
Yeah, that's fantastic. And I so want to ask more about the details of how you brought image search into, if I'm understanding correctly, kind of into other models, right? So
Yeah.
you're using almost image data as features for other types of questions that you're trying to answer. Is that right?
Absolutely, and that will be the topic of my talk tomorrow morning. So
Amazing. So there's a little taste for you for tomorrow. And Jimmy, last but not least, on impact.
Sure. I think I want to talk about a biggest failed success, I think. So back in 2007, 8, 9 timeframe, we had a small company called SearchMe. It was a search engine that we built from scratch. And the difference was, instead of getting 10 blue links, you got 10 images of the web pages that were the results for your query. And over the course of a year, we built a ranking function from scratch. Traditionally, ranking functions were maybe Boolean-type queries, and we built one using machine learning. And at the time, that was pretty innovative. And I was very proud of our result. And we kind of improved our Boolean ranker by about 50%, 60, 70% over the course of a year. And it was unfortunate that this was about 2008 timeframe, and as a startup, we ran out of money. And we invested about maybe $10 million in hardware in the cloud, instead of going with AWS at the time, I guess. But the point is that everybody was impressed with our ranking function at SearchMe, and we compared very well against Google, Microsoft, and Ask Jeeves, and so on at the time. And so we were using machine learning in a very innovative way, I thought, and for labeling purposes and also for ranking purposes.
Yeah, that's fantastic. And I think for those of you in the audience who aren't at least looking at how you apply things like learning to rank into your algorithms, that is definitely something that should be on your radar, especially if you're in a more consumer-focused world where you have a lot of feedback around that. And, and for the people in the community as well, this is a really important thing that Solar and Lucene need to be able to essentially provide better infrastructure and capabilities around. I think continuing on, I think that's probably a good segue of, you were ahead of the curve in 2007, 2008. There was definitely academic research around learning to rank going further back. But maybe, Kamelia, if you could just kind of, give us kind of the state of the art around retail search these days. You obviously have a pretty nice overview of what's going on at places like Overstock. I know you're in the very active in other communities around machine learning. Kind of, how do you think about the state of the art when it comes to e-commerce search these days?
Yeah, I think a lot of research is being applied for e-commerce, specifically in deep learning space. Like I said, to take advantage of alternate modalities to address issues like tag stuffing, for example, for an e-commerce place, right? Or making sure what you're showing, you have the style, for example, inferred as opposed to necessarily just appearing in the text. Because e-commerce is a very special case of search, I would say. Not only has different types of data that you can take advantage of, but not all of them are equally reliable. I would say image is one of the ones that is actually really reliable. There is a lot of research right now in terms of getting learning to rank models into production, right? So I would say historically, there has been a lot of research on point-wise, pair-wise, list-wise kind of like approaches to doing ranking. Right now, I see a lot of research on multimodal ranking, which is taking advantage of images and adding all of those into the ranker itself. And there's a set of research in terms of the actual ranking models too. I'm excited about ensembling, and my team actually knows this. I keep telling them oh, have you tried an ensemble model? So that's, I think, the way the research is going to go for e-commerce search. The second aspect of it is actually establishing kind of like a correlation because e-commerce search is where you get most of your conversions from and most of the revenue comes from. So experimentation there is pretty expensive. So if you go into production with an experiment, you want to make sure the experiment has some sort of success rate, offline, guaranteed. So there's a lot of research that goes into establishing online performance versus offline model performance correlation. So that's exciting too.
Very cool. I'm just curious from the audience perspective, especially those of you who are on the consumer side of the equation, just a show of hands, how many people have looked at or maybe are thinking about incorporating image data into their search function, into their ranking models, those kinds of things? Yeah, so this is an area I think that a lot of growth opportunity for this community to think about is how do you start to leverage that? You know, that proverbial, a picture's worth 1,000 words. Yeah. I mean, a picture's worth 1,000 vectors. Is that the new model there?
Yeah, that's. I'm going to choose that as a topic of my next paper.
Now, Jimmy, I know you work across a lot of other types of search, in particular some internet search companies that shall remain nameless here, but maybe you can broaden out the perspective for us a little bit and talk about what you see in terms of best-in-class ranking approaches and intention, discovery, those kinds of things.
Sure. Well, I'd just like to build on the previous point. Multimodal modeling is really it's leading to great results, and we're looking at not just images but video and sound clips as well. And if we look across like retail, which is talked about, and I've got some clients in the retail space incorporating these. Being able to take an image and maybe generate a caption for that image can be already a very useful piece of information for helping with ranking. And we have lots of problems in the cold start front, and being able to take some of this data in that way is also, and so those to leverage those multimodal data, we definitely have to call upon deep learning to do a good job. And as Kamelia was saying, the using deep learning in practice is very expensive. But luckily, a lot of these activities are done in a batch upfront, offline, so we can afford to have to process this data. And so when we look at retail, when we look at consumer. Products and ranking engines. There's I guess people are starting to go from just taking the raw data that's in front of you and also to basically generating data as well. And so we're getting into this world of generative adversarial networks where we're actually starting to generate data so we can get through cold start problems in a very creative way. And this is a very new breaking field with lots of really promising results. But it's still hype, I guess. But we're still trying to ground it with successful applications.
Yeah, very cool. A lot of good things. Again, like I feel like all of these topics we could just have full day workshops on probably. I want to shift gears a little bit, Nick, and you've been at you mentioned Reddit, you're at Looker these days, you did Power BI, you've been at these places where you've been building your own stack, you're building data products at the end of the day. And so I imagine then you spend a lot of time with customers who are struggling with these data problems. What do you see as kind of some of the main challenges, and how do you think about how we as engineers can help build out better data products that are more amenable to solving these kinds of problems?
Yeah, that's a complex question. I'll start with the basics, because to be honest, most of the customers I work with on a day-to-day basis aren't at the level where they're doing complex models. I think if we're being honest, like that's actually a fairly narrow slice of what people are trying to accomplish. But there's a swath of people. I bet most of the people in this room spend, if you're being honest about what your data science team is doing, they probably spend most of their time like fixing data pipelines or doing data cleansing. Yeah, I see a lot of head nods. There we go. See, I got a woo. Yeah. So yeah, I think like from my perspective, you've got to get people access to the right data so that you don't end up in situations where people are arguing over metrics. Like I've seen this. I've lived through this personally. It's really embarrassing to show up in front of your board with 3 slides with 3 different definitions of DAU, ARR, et cetera. And I know I'm not the only person that's happened to. And it's because what you see in a big enough company is maybe there's a lot of data laying around, but it's not governed. There's no single definition of the truth. So different departments, like the marketing department might have a different definition of DAU than the sales department, which is different from the data from the core product team. So I think like before you get ahead of yourself and start trying to do all sorts of complicated machine learning modeling, you have to kind of assess whether or not your data is trustworthy and whether or not it's actually landing in the right parts of the organization to be useful. So have a plan around like who has access, where is it going to be used, and what your common definitions are.
Nice. You mean I can't just throw it in a data lake and have it all solved?
I mean,
doesn't work?
I think, look, modern architectures, I think, do support putting lots of data into a data lake, but what you need on top of that is something which governs what's in the lake. Like the mistake people make is like, oh, it is in fact, if any of you are not currently using data lakes or like modern MPP data stores, you're probably doing the wrong thing. Like don't beat me up now, but I'm just telling you the technology has advanced to the point where using data lakes is very sensible. But with great power comes great responsibility. Like if you just let your company willy-nilly go straight against a data lake, you're going to introduce all sorts of problems. They'll feel empowered, but no one's going to agree on definitions, and you'll create all these other secondary problems.
Yeah, and that's probably actually a good segue, because I know obviously Cloudera is in the data lake business, and you run a team of Alice. You run a team of data strategists, and so I imagine you spend a lot of time kind of helping them think about all these bigger problems. What are some practical tips that you have around just like I wish every customer knew this before they got started?
Yeah. I think sort of playing on this data lake idea, we get a lot of, so we work mostly with enterprise clients, and they're typically large and older companies that are trying to use data now. And they got the message a couple of years ago that they should start collecting lots of data, which is great. We're not in a place where we're starving for it, at least. But I wish they had, at the outset, tried to figure out what they were going to use the data for. Just collecting it doesn't really help anybody, especially when it's not governed well, and you don't have consistent schemas, you don't have access controls, you don't know where it came from or how it was originated. So I think my biggest thing I wish all of our clients had done would be to think forward what they were going to do with the data, like what use cases they were going to work on, what products they were going to build with it, and then start from there in terms of the collection and then the team they were going to build around that.
Yeah, lots of good tips in there, and I know we're definitely going to want to come back and talk about the team. If anybody does have audience questions, please do make your way to the microphone. And in the meantime, as maybe one last question on this kind of production side of it. I mean, there's been a lot of talk around deep learning, and I want to kind of just get a sense from actually each of the panelists of how you think about deep learning in your practice. Do you even think about it? Is this something you tell your customers, hey, you should care about it, or do you have a specific type of customer that, okay, you can do deep learning, but you can't do deep learning? So maybe, Alice, let's start off back with you on that one.
Yeah, so as a group, we think a lot about deep learning. We just had another research report, so we do research and the sort of advising and consulting on deep learning to do an update. So we work with a lot of our clients that want to do deep learning or implement it. I think that a good portion of them don't need it, so we sort of shy away from that piece. And then for those that do, it's a really interesting sort of like digging in as to the why they would need it and what they would need to support that. But I think it's not something that everybody is using all of the time, which is what it can sort of feel like. And then the other piece of it is as this has advanced over the last several years, we wrote an original report several years ago saying deep learning was going to be big, and it was, which is great. And this sort of like update piece is more around, okay, so what is this doing? What are the model architectures we need to work with? And talking to our clients about, do you use a pre-trained model to start with, right? Do you use some sort of auto ML? If you do really want to get into this, do you actually have labeled data? If not, then we need to stop here and kind of get back to that place.
Gotcha. Yeah, no, lots of good stuff there. And maybe Jimmy, I know you probably spend most of your time on deep learning these days. Is that a fair statement? So, how do your clients think about deep learning with you?
So I think I got two types of clients. One type of client is focused on transactions, like maybe millions of transactions per second, and they could be queries, they could be purchases, they could be clicks. And in that world, it's not really realistic yet to have a deep learning deployment. It's very expensive, and the cost per operation is really a lot. And so we typically use deep learning in the batch upfront training and preparing models. But when we deploy models, we try to simplify them so that we can run them at high speed and get millisecond turnaround times. And then the second category of clients I'm working with is more dedicated applications, and Grant mentioned up front that I'm working on self-driving cars, and so there we have dedicated hardware that's available to us, and typically that hardware is high-powered GPUs. And I don't know if you've ever looked inside the under the covers of a self-driving car, but there's about maybe 10 or 12 different steps to keep a car on the road and get you from A to B. And so we're processing a lot of sensor data from images and LiDAR and radar and so on. And then we're working with super high definition maps. And there are maybe, let's say, 10 or 12 steps that we have to get through where we're using machine learning pretty much for every step. And the machine learning we're using ranges from typical classification, image classification, object detection, but then we're also tracking these things over time, and then we also have reinforcement learning aspects of these where we're trying to learn policies that keep us in lane and help us avoid collisions and so on. And so for those types of tasks, deep learning is really the only way to move forward. People have tried and got a certain level of success from traditional approaches, but deep learning has made the big difference, I guess, and it's a necessary a component to these pipelines. Whereas with the more transactions, like Kamelia was saying earlier on, for retail, it's a transaction-oriented business. You can't afford to run deep learning quite yet, I guess, and that's kind of the two buckets of clients, I guess.
Yeah, so an area of pretty active research, I imagine, is how do we make this scalable to handle? And I believe you said the millions of transactions a second. So, yeah, that's a definite challenge out there engineering-wise. I think actually I'm going to cut that one off a little bit just in the interest of time. I'm noticing my schedule down there, and I think we've got one question back there from the audience. So how about we transition into that?
Yeah, hey everybody. So I'm hearing you loud and clear on feature engineering and data prep and cleansing is a big problem. How are you solving this? Are you hiring more people or getting better tools, or how are you attacking it?
Jimmy, you want to talk about that one?
Well, I think that, okay, so again, coming at the world from a deep learning perspective, we're starting to shift the emphasis away from, well, there's definitely data prep that's still a big problem and a challenge. Feature engineering is something that we're kind of pushing into the learning algorithms in a deep learning front. And so basically, in deep learning mode, we're focusing more on the architectures, like how many layers in a network, what type of structure do the layers take, and then also we're focusing on cost functions. Should I have a mean squared error loss function? Should I have a single head or a single output layer, or should I have multiple output layers? And so we spend more time on doing the architecture engineering as opposed to the more traditional feature engineering. But the data prep is still a very much a required step as well.
And Kamelia, how about you?
So,
Just in an e-commerce setting, and then Nick, and I know you care deeply about this too, so I want to make sure we balance it out here.
Yeah, I agree with everything Jimmy said. I think one other aspect of it is we are hiring more people, of course, but the other aspect of it is storage of features, right? So a lot of times I think what happens is people continue reinventing the wheel for a new problem without actually noticing that a lot of the features are reusable, right? So I think one thing we do really well in Overstock is that we have a feature storage for customer representation. That could be your SVD vector, for example, from a recommender system, but it could also be applied in a personalized search context. So just having those intermediate data set be actually really good documented and available to other applications solves a lot of the problem. Data prep, I guess, it's actually something that you might be more interested in.
I do care a lot about this, I think like deep learning aside, one of the maybe hidden and gigantic shifts happening at the moment with respect to data is changes in how data engineering and data prep happens. So in the past, I think what you saw was, particularly in the BI space, a lot of excitement about giving everyone access to data and making sure that every department was empowered. But that was at a time when I think we were still trying to promote data as a thing that made businesses more powerful. Now, if you said data doesn't make businesses more powerful, you'll be laughed out of the building. Like, everyone assumes that they need data. Like, not even execs. Like, we have a customer that uses data to empower pizza delivery drivers to be more efficient. And the pizza delivery drivers get that, like, a machine learning model is telling them where to go. So everyone needs data. The flip side of that, the problem now is you've got so much data coming from so many different places. Like Looker, we've got literally like 140 different SaaS applications that we try and pull data together and model it and transform it and link it up. And we're not even that big of a company. Like, the average enterprise has about 1,000 different SaaS apps or data sources that they're trying to bring together. And that's rising. So if you think about this, we got like a big problem. If you care at all about data prep or data engineering, you simply cannot use the previous generation's approach to handle what's coming, because what's coming is gigantic. So anyway, to answer your question briefly, it's a return to governance. You know, in the past, I think it was awesome that everyone could get their hands in the cookie jar. But now I think the role of analysts and data engineers and data scientists is to make sure that everyone has one view of the data that's trustworthy, and that data engineers have been really underserved for the past decade with the tools that they've been offered. And I think that has to change. Give data engineers, data analysts better tools to empower the broader organization is how I would answer that question.
I think that's a great answer. So the answer is yes to all your questions, right? I think we've got one more audience question over here, and then we'll continue on.
Thank you. My question...
Go ahead.
It's on now.
Yep. My question is about the user experience related to all of this magical analysis that's going on. That there's lots of examples where there's incremental improvement, where it doesn't really change the experience, it just makes it a little bit better. So recommendation engines are a good example of that. But there's lots of examples, I guess, where there's significant changes in the way that people interact with the technology. And I wanted to see what your thoughts were on that, and about how, if you're managing a product, managing the software, and you've got these steps, significant changes in the way that people can interact with the software, how that should be managed, and maybe you've got some stories about how that step change, that quantum change, has actually played out.
Alice, I think that probably feeds into your view as a strategist, right? I mean, you've got the title, so let's use it.
So I think two things. One, a lot of our work that we do is, and we have this little tag phrase to make machine learning boring. I think as this whole field has evolved, it's become less magic and less flashy, where people feel this sudden punch of, I'm interacting with something that's not straightforward. It's a machine that's doing this, and it's learning in an interesting way. So I think a lot of the applications and a lot of the products that people use today feel intuitive. On the flip side, over the last several years, I've noticed moments, and I think there will be a lot more to come, where things flip really quickly, and things that weren't possible maybe 6 months ago are possible today. One of those things I've seen has actually been, in the realm of deep learning, when we talk about images and being able to surface images or tag images, and people having this new way of interacting. And I think from a product standpoint, giving people the experience, but also sort of the tools around how do they start interacting with that shift. And I don't know that falls on the people creating the products necessarily, but as they start to be adopted en masse, then there is a need to educate people and to have them feel like, I guess, they're safe and that this change isn't really scary for them.
Perfect. And I think, hopefully, I don't know if that fully answers your question, but I think just in the interest of the time, this is actually a good segue, because I think the first question was kind of like, hey, are we hiring more people? And in many ways, this also highlights there's these other aspects, because I think many of us who are especially engineering-oriented or data science-oriented is like, okay, well, let's go just hire a bunch of pipeline engineers and let's go hire a bunch of algorithms people, and job is done. And yet, here's a question around user experience. There's questions around people who are doing annotations. I guess, and again, kind of for each of you, maybe just one or two tips on how you think about hiring and building out a team that helps you actually solve the bigger problems, not just the, oh, hey, I'm going to go apply logistic regression, or I'm going to go apply deep learning. And maybe Kamelia, start with you.
Yeah, so when we build a team of data scientists, I think one thing I really value is having diverse backgrounds. It's people who are equipped from many different disciplines. We have people that come from economics background. We have people who come from astrophysics background. The common theme between them is that they're actually really good at problem solving and handling data at scale, and they communicate with engineering really well. So those are all the skills we look at when we're trying to find people to build our data science team. I think actually communication skills there helps a little bit too, because a lot of times data science, machine learning is really misunderstood by the business units or product teams. They think it's like a magic silver bullet that you can just like put machine learning on it and the problem goes away. But that's of course not necessarily true, and sometimes the benefits of the machine learning model is not clear to the executives, for example. So to have that communication is actually quite helpful for us too. But I don't necessarily think we require a specific type of background, which I think is a very controversial subject.
Sure, great. We like controversy. Nick, I mean, you come at a lot of this from a product management side. How do you think about that from a chief product officer standpoint?
Yeah, I mean, I think there's lots of different types of product managers. And it depends what sort of product you're building, to what extent you're going to lean on data. Like I'll give an example. Like I once had a problem, like back when I was at Microsoft, where we had this technology that was like super whiz-bang, propeller head kind of stuff. It could look at your email and automatically detect whether or not there was a task in it, like someone's asking you what to do. And it was like 85% accurate, and we were like, this is amazing. So the 1 PM we had on it was off trying to like convince everyone that this 85% accurate task detector should be integrated into the Exchange email pipeline. We had another PM come in. He was only in the project for like 2 weeks, and he was like, hey, why don't you just make it so if you can highlight the text and click a button that says add task? That is the thing that actually shipped. So when we think about how we use data and the experiences, it has to be grounded in like, are we actually solving customer problems? So that's what I look for from a product perspective. I try and shy away from people who are overly enthusiastic about the tech because it has to be grounded in like satisfying a customer's need.
Yeah, that's fantastic. And I think both Alice and Jimmy, you probably can come at this from you're actually hiring people who have to go out and engage with other customers across the whole stack. So maybe Jimmy, starting with you, like how do you think you not only need the communication skills, but also the, in Nick's words there, the propeller head skills too, right?
Sure. Well, I think that just data science is great, but I think it's like we've had data science version 1, and we should be thinking about version 2, which is more AI-centric. And so when we think about AI, we're thinking about a system that maybe has the 5 senses. You can see, you can smell, and taste, and all that stuff. So we're being very we're not being very ambitious when we're talking about data science, I think. And I think that as a result, we've kind of got an industry going here. It's just really successful, but I think we need to be a bit more ambitious. And there's a lot more possibility out there. And so with your product here, Fusion, you're starting to deal with the 5 senses a bit more, which is really great.
We don't have the smell part down yet.
Okay. But so as a result, we've got an academic world that says, hey, data science, everything. We have degrees on data science, but we should be really broadening our horizons here and taking in these richer sensors and dealing with perception and decision-making and closed-loop decision-making in particular. And so when I talk to clients and I say, look, if you think about a marketing problem where you have a consumer, you understand the consumer, you perceive the consumer, then there's certain actions you can take around the consumer. And these actions today are generally just one-shot decisions that you make about your consumer. I'll show you an ad, I'll give you a phone call, send you a text message, coupon. And it's not about managing the long-term lifetime value of your consumer. And if you focus on the world that way, you're looking at a closed-loop decision-making system using things like reinforcement learning. It's a hugely ambitious approach, but I think there's huge value in investing in that. And when I talk to customers, they get super excited about it. And then there's a bit of fear that creeps in. And then when we look at the numbers, greed kicks in. And so I think we need to go beyond data science as my bottom line here and be more ambitious.
Yeah. Fear and greed probably underline most business decisions right there. I'm going to actually skip ahead here just because I think in the interest of time, I want to make sure everybody has a chance to get to the party afterwards here. And so I'm going to skip ahead, and I think we've got some good audience questions around, and we're running a little bit late, so I'm going to go over a little bit here. But this is perhaps a good segue into, you talked about fear and greed, and that probably drives a lot of decisions that people make in this. And perhaps that's a little bit of a good segue then, and looking at you, Alice, around how do you, perhaps share some of the battle scars you've gotten around putting AI into production, some of the places where you thought this was going to work and it just didn't work. Or maybe it took you longer than you thought,
Yeah, I think there's a whole dustbin full of failed models and things that just didn't actually work. I think in general, when we talk about failures of sort of along the fear end maybe, but also in terms of being realistic about what people should actually be working on, we get in, in the business I'm running now, we get into a space where we're watching other people fail, I guess, at this point, and saying, well, I told you that was going to happen. Maybe you shouldn't have done that. But those places are actually in not having well-defined problems. So really starting with that point of, I actually need this technique, and I'm going to invest in it. And the really epic failures are when people get really attached to the buzzwords and they really go full steam into one space without thinking about what they're actually going to do with it or what 15 other things they're going to build from that investment. And the other piece is not being able to put things into production, which is a huge problem for everyone.
Yeah. Hey, Kamelia, maybe I think you mentioned some good stories backstage. I don't want to put you on the spot with them, but maybe highlight a few where something where it took you longer than you thought, or or maybe the models just didn't quite work out in your favor?
Yeah, so I have quite a few examples too, but I think the one I want to highlight is in search actually. So when I first started running learning to rank experiments in search, I thought it would be a really quick win, and I think it took us a year to beat a simple production model, and iterating on it a lot, which was really interesting to see because there's just so many models that fail to scale, the infrastructure has to change, the real-time data access, all of that. The other aspect of it, which was interesting, is one time we actually did put a learning to rank model in production against another model, and I was really surprised because after a while I was looking at the results, and the model that was obviously worse was actually learning alongside the other model. So we discovered a whole set of issues in data contamination on the training side. So basically model B was cheating from model A's training data,
wow.
which is really interesting because they were really performing the same, and once we decontaminated the data, they started kind of drifting apart, which was really cool to see. But yeah, there's a lot of models that have failed, but I always tell my teams, machine learning and AI is just all about iteration. There is no right answer, so just put the first model in production as a baseline as fast as you can, and then continue iterating on it. There's always new models coming in from deep learning, feature engineering side of things, from the actual modeling techniques, but if you never get that baseline in production, you can never improve on it. So that's the whole idea behind the experiment-driven culture that we have.
Yeah, I love it. And just to make sure I heard you right, you said that very first learning to rank model that you ever put in production took over a year to get right. Is that right?
Yes,
Wow.
to beat the production model. Now, granted, the production model has been had a lot of business rules that has been built into it over the years. So it was fairly intelligent, but I was surprised. Put up a good fight.
Yeah, and I mean, I think that's one thing to keep in mind for the audience, especially those who have been running search for a long time, right? Is, you've done a lot of hand tuning over the years. You've got all these rules, and that can be a tough thing to beat, right? I mean, I think I want to then, shift gears. I know we're almost over. I'm gonna take founder status here and go a little bit over, but I want to hit on at least, one more topic around kind of this idea around failures and biases. And I think it goes back to what you brought up at the very beginning, Alice, around interpretability. And so since you brought it up, I'm actually going to ask, Nick to think about this a little bit more of how do you think about helping your customers understand what the heck all this stuff actually means in terms of interpretability, and then we'll continue on, especially around the deep learning pieces.
Well, I might answer it in the exact opposite, which is most of my customers don't care to interpret the models at all. And if that were ever to be exposed to them, it would mean something had gone critically wrong. So our product is really about empowering everyone in an organization to make use of data. Now, if you narrow that down to a much smaller group of people, say analysts or machine learning engineers, those folks probably do need to interpret models and so forth and so on. But that's also only representing 1 or 2% of any given enterprise at best, all right? Most of the folks are just trying to get their job done, right? If you think of most of the people who are in an enterprise and take your biases toward data out of the picture, it's like salespeople, marketing people, these sorts of folks. And one of my favorite examples, going back to the delivery driver example I was talking about earlier, we have a company that uses our product, and on the back end, it uses a machine learning model with a little bit of predictive analytics to basically say where delivery drivers need to be at any given point of day to optimize their fleet deployment, all right? Now, can you imagine if I took the model for that and actually exposed it directly to a pizza delivery driver? This is not a sensible thing to do.
Yeah.
So I think a pizza delivery driver needs a one-line text that tells them where to be at any given moment. That is the interface they need. Underneath that, it can be as complicated as you want. But if you're really trying to use data to service everyone in an organization, you have to be very, very thoughtful to have it appear to them in a way that is useful in the context that they can understand and is actually going to help them accomplish something. Otherwise, you're just kind of playing around. So.
Yeah, that makes sense. Yeah. And Maybe Jimmy, turning to you on this one, because especially in autonomous driving research, there's the proverbial ethical question of do you swerve to the ditch and kill the driver, or do you hit the pedestrian? We won't go into that one, but I imagine this is up for a lot of discussion on some of these projects of like, how do you actually know what the decisions the car is making? So how do you think about this problem of interpretability and explainability?
So first of all, not a lot.
Okay.
Well, in the sense that we've got concrete problems to solve. So we need to recognize objects in images, and that's just one concrete. And so if we have LiDAR, we have 3D space to work with, and so typically, some of these models can be, let's say, hundreds of megs in size. And the architecture of these models can range from 10 layers to maybe 70 or 80 layers. So you can imagine trying to interpret those 70 or 80 layers or those couple hundred meg of coefficients in your weight matrices. So it's kind of a little bit of a lost cause to say we're going to have explainability. But we do try to do certain things. We try to push data through the models and see which nodes light up and what they focus on, but we get certain level of insight. But coming back to the kind of overarching goal about kind of safety, ethics, and so on, that's an ongoing, I guess, conundrum we find ourselves in, and so. And so some of these models are they're rule-based models. So say, okay, so you do your perception and classification, then you do some reasoning, and then you prepare a plan to say, okay, press the brake, turn on the turn signal, and move out. So basically, those are kind of reasoning-based systems, and some of those are rule-based systems. So if certain conditions are true, then you do certain actions. And some approaches today have this manually curated rule-based system, but increasingly we find ourselves moving into reinforcement learning, where these rules get much more sophisticated and less transparent. So with the rule-based models, it's kind of you can control and really understand what's going on there, but with the reinforcement learning systems, they get a bit more complicated. And so the reinforcement learning systems are, I guess, a bit more versatile, and they cater for a lot of maybe more unseen cases, whereas the rule-based systems, you have to enumerate and maintain these rules, and it becomes a bit of a burden. So we're torn between moving forward with some excellent results, with some, as opposed to staying with some mediocre results with the hand-curated rules. And so we're still trying to figure out how to deal with the moral dilemmas. And so we typically also, I should say, we're very conservative. We don't really say, hey, just go straight ahead. We will stop. We'll just get very sheepish about our movements, and we'll just shut down. And generally, that's the case.
I've got a lot of years under my belt of writing mediocre rules systems, and so maybe, Kamelia, final thoughts kind of on how you think about this explainability problem, and then we'll finish up with one final question for all of our panelists.
Yeah, so I guess we heard a lot of examples, and on the side of we don't need it, I want to bring up an example on the side of, well, sometimes we do need it, and it might be something that we want to consider based on who the customer is, right? Maybe if the customer is the pizza delivery person, like you talked about, maybe we don't need it, or for autonomous driving, although it would make me feel more comfortable. But in a lot of cases, for personalization and recommendations, for example, if you think through it, I think it's a very sensitive subject, and sometimes people don't like the recommendations that they're seeing, or they don't like the personalization they're seeing. They would want to change the style of it. So they have to have a way to be able to interact with the model. We actually just recently published on this is using deep learning, kind of create a latent space of styles for different items, for example, that you can push one of them up and the other one down and render the entire page for you in a different style, so to escape that filter bubble, for example, right? Because if you don't have those levers, the same thing is going to happen over and over again, which is why the ads follow you from Facebook to your shopping experience and so on and so forth. So I think sometimes it's actually helpful to know what the model is doing. And the other aspect of it, which is also helps is when there is bias in the model, right? It helps to see why the model is actually making a specific decision, and there are use cases of it that could be really helpful to know why the model is making that decision. So there was a really good KDD paper on this, on I guess criminal justice, for example. That uses a set of features and kind of identifies who is more likely to be a part of like a group of people and what should be applied to them. And in those cases, there's severe bias in the data. But if you don't know what the model is doing, you can't go in and fix it, right? So I think there's a lot of examples like that too.
And imagine maybe it's just one final thought on this, Alice, of talking, kind of picking up on Kamelia's theme there. Especially I imagine you work a lot with banks and the like, and this question around bias, I'm sure, in the data comes up quite a bit. How do you help your clients think through that problem?
We do it in a couple of ways. So in any kind of regulated industry where you're making decisions about someone's life and what they have access to, you have to understand what the model is doing. Per law and then per just good building practices. So we help people think about it in ways of what data they're bringing in, what features are you even allowing in your model? Do those seem reasonable to you as a human being to make a decision about somebody's life? Being able to reliably report the extent to which those have influenced the model to somebody that would ask later. So that could be a regulator or an end customer. And that doesn't actually rule out for any of our clients really more complicated models or even using deep learning. There are a lot of models you can put on top of these. Lime is one of them that we've gotten into, but we can sort of make those recommendations. Once you've found a model that works for you, how do you make it interpretable? So you have data, you have the model itself, and then you have how you choose to implement that model and the amount of sort of power that you give that. So at what point does it roll back? How are you maintaining that model and making sure it doesn't drift to a certain extent where you're not comfortable with the performance in these or for these specific groups of people?
Yeah, fantastic. And I think, like I said, I'm probably the organizers here are saying, hurry up, Grant. And so maybe there's just one final question, I think, for each of you. And this one I truly want to be short. And that is, that this field is, I think, in many ways, we would all agree, is at a tipping point, right? And it in many ways needs to live up to the hype. And so Nick, starting off with you, and this is actually a question that Alice gave to me in the prep work, which is, what should we be doing today to make sure that we're not headed for AI winter? How do we make sure that, we're laying the groundwork for this next generation of, as I like to call them, AI native engineers and scientists can do the right thing. They can ensure the success of all of the work that's being done now.
Yeah, I guess I'm really practical, so I'm not going to give any really highfalutin answer. I mean, very practically speaking, choose the right data stores. If you're not using a modern, massively parallel data warehouse in 2019, definitely go do that because it makes it much, much easier for you to handle your data engineering tasks. Once you've done that, think about governance. In a world where everyone needs data and the number of data sources is increasing, it is going to be exponentially harder to trust that data. So make sure you have a governance layer and you've been thoughtful about making sure everyone has the same view of data. And then the final thing is, if it's your responsibility to empower people in your organization with data, I think the rules are now different. If everyone needs data, that means it can't be held within the walls of the business intelligence department or the growth team department or any particular silo. So the job of the analyst or the data scientist now, I think, becomes empowering everyone in the organization with data, and that may mean that the experiences or the interfaces surface in radically different ways than they have in the past. So.
Yeah, fantastic. Jimmy, turning to you on that same question of just minute or less, what's the foundation we need to set now?
Okay, I think we need to set our sights higher and really embrace AI. But I think that our education system on machine learning and data science is very old school. And I think we need to rethink about how we educate the next generation of machine learners and data scientists and AI folks. And so, for example, we spend a lot of time saying, here's our traditional pipeline, 6 or 7 steps of understand the problem, grab the data, cleanse it, transform it, model, lab tests, all that stuff. But I think that we need to think about machine learning in terms of the tools we have today. So if we look at TensorFlow as a kind of a modern stack in machine learning where we have auto-differentiation built into that tool, when we think about machine learning then, we just think about expressing loss functions and we think about expressing architectures. And so not many people have done a multi-input, a multi-head, or multi-output layer architecture in neural networks. And so those are the things that are really changing the way. And so in computer vision, we're doing this all day, every day. We have multiple output layers, multiple inputs, and really it's kind of setting a standard for other fields. And so we'd like to see natural language processing follow suit and be more aggressive on having more complicated architectures, more complicated loss functions, and we should start in the education system, I guess, and work out from there.
Fantastic. Camelia.
So I totally agree with Jimmy. I think we should be a little bit more ambitious in the use cases of AI. I think there's still a ton of use cases that we haven't unlocked. That is 100% true. I think the other thing is we have to lower the barriers of entry for people to actually get to play with AI. I think a lot of times just because of the hype around the field, or I don't know, maybe it's like the research papers, it just seems like you have to be really, really an expert into it. And I just want a world where people feel empowered to experiment with AI. Not everybody needs to understand the whole landscape of machine learning. I certainly don't. To actually be able to start experimenting and coding one of these things into production and seeing how it actually operates, which I think is something that everybody should start doing. I often think just taking Coursera courses, maybe we can do that as part of our education system. Just start playing with it. The sooner, the better it's going to be.
Fantastic. Alice, this was your question, so I'm going to leave you with the final thoughts on it. You get to answer your own question.
Yay. That's the easiest one. I think if I'm advising people for the future, two things. I think businesses need to start thinking about the way they choose data products in more of an investment blended space. So shoot for really out there things, absolutely. Have a solid base of things that you know are going to work, that the business will continue investing in, so that we don't have this shrinking of investment. And the other piece, I think, is we have to move beyond deep learning. So I think causal models, probabilistic models, everybody should be trying to find ways that if they have problems they haven't solved already with deep learning, they should be looking at other options now.
Fantastic. So you heard it here. We've got to get beyond deep learning. Many of you probably aren't even on deep learning yet, but so we're already moving past it. Don't worry. So how about this? How about a big round of applause for our panelists? Yeah, thank you so much to each of you. I know many of you traveled from quite far away. Some took the train this morning. Many flew in ahead of time. And so, a huge amount of appreciation for each of you for coming out. And I also want to just take a moment to thank all of you as the panelists here. Some of you may have heard I'm actually moving on from Lucidworks here. And I wanted to just give take a little moment for what is a pretty bittersweet moment for me to just thank all of you who have been coming, churning out, showing up, giving me a lot of the energy that has really fueled what we've been trying to build here at Lucidworks, what we've been trying to build here with Activate. And so if you don't hear it from me in other ways, especially the customers and the team at Lucidworks and all the people in the solar community, just a huge heartfelt thanks to all of you for all you've brought to me over the years. I can't tell you how appreciative I am of the support you've given this company and me personally over the years. So thank you very much and enjoy the rest of the show.